they can do. And of course, these are the various core disciplines of medical laboratory science. And of course, one of our joy as a medical laboratory scientist or the medical laboratory profession is the multidisciplinary profession that we have. And these are just few. I could list on and on, you know. And of course, we all know that even IVF, in vitro fertilization, is also part of the core mandate of medical laboratory scientists. And of course, without mentioning names, we know medical lab scientists that are making wave in this particular field. And yes, I remember even, well, now, I'm also part of Osun State University now, you know. And I remember when we were graduating students at Lautech, we talk to our students and we teach them, you are not only to work on the bench or in the hospital. And the kind of training we give have taken to several companies like Nigerian Breweries, Coca-Cola, and we still continue to take them on excursion so that they know they are not limited to working in the hospital. And of course, from their clinical years, 3 to 5, the various courses we offer in medical laboratory science profession, which I know is not different, it's all over, which is regulated by the NUC and the Medical Laboratory Science Council. It has different courses that are a profession. Instrumentation is part of the core course we can do, and bioethics. I know a colleague in you that is, I call him Professor of Ethics. You know, I'm sure some of you know him. KSA Oyedeji. He talks, anywhere he is, he talks about ethics. And of course, as medical laboratory scientists, I mentioned about quality. We are guided about morality, quality, standards, norms, normal way of doing things. Because our work is procedural. So if you're not guided by all these guidelines, we are probably going to miss the way. I mean, of course, it's like a kind of stereotype. If you then want to go outside of your procedure or norm, then you may have to prove it beyond any reasonable doubt that this is going to work, this is going to give us the same or a better result, and it must be reproducible. So we have there's an ethics in healthcare setting, which we call bioethics of standards. I need not say much of analyzing samples or diagnosing and treating patients. And of course, research. Even those on the bench, I tell people that what we do as a medical laboratory scientist on the bench, it's about 70 to 80% research. Because if you take certain sample sites and all of that, what we do on the bench is not too much different from research. And that is why many laboratory scientists in academics are excelling, because right from your student days, you have been exposed to research activities. And of course, pharmacology and toxicology is part of the courses we do, of course, which is closely akin to pharmaceuticals. And of course, quality management and assurance, which is also talking about quality and so on and so forth. Now, let's look at our role outside of the hospital or the bench or the laboratory. And, you know, in a wider sense, we are now involved in forensic science, in pharmaceutical industry, vaccine development, food industry, research and development, like I mentioned the other time, academics, and entrepreneurship. And I will take this briefly. We all know what forensic science is. Forensic science is application of molecular biology in detection of crimes. And this professional or this forensic scientist, which we also could be part of if we are so rich, can unravel so many things. They work in the bank, you know, they work with security forces, DSS, police, and so on and so forth. Next slide. And of course, the broad field entails detailed DNA analysis, fingerprint analysis, and fingerprint analysis actually is the major technique that is used in a crime scene. And of course, we have firearm examination and ballistic, and so on and so forth. And this is just showing what a forensic science do basically. Next slide, please. And if you look at that, that's the fingerprint analysis, and the criminal forensic is taking a sample, like a strand of hair from a crime scene, and of course afterwards they're going to do DNA extraction and for further processing for fingerprinting. In the pharmaceutical industry, we all know the chemicals we use, the drugs, antibiotics, vaccines are all produced from pharmaceutical industry. And medical laboratory scientists play vital role. I know a lot of medical laboratories, especially in the area of vaccine development and the quality control of any of these pharmaceutical products. Because there's no way you produce a pharmaceutical product that you will not check whether the product is sterile, is devoid of any microorganisms, and of course, and the quality. Those in chemical pathology, you also want to check the quality of what you have produced. And of course, we know that the first penicillin, which is the first antimicrobial agent that was discovered, you know, and I mentioned pre-laboratory era the other time during the First World War, that a lot of people were dying. And penicillin came in the 30s, but it came into commercial use during the Second World War, and it helped a lot in healing and treating soldiers in the war. And of course, and that was discovered in the laboratory. The purification and commercial production, of course, is also not, the laboratory is also not left out in this. And of course, vaccine production, up to now, 40 years, HIV vaccine, you know, and it is the duties and the responsibility of medical laboratory scientists to research and work on production of vaccines. And food production, be it beverage, different kinds of food, medical laboratory scientists are very, very important in the quality control unit. Thank you. We can't be talking of all these various things. For instance, we are talking in a microbiology lab, it will take a minimum of 3 days for you to do microscopic culture and sensitivity. But there are technology now that within 4-6 hours, Vitek, Multitop, within 3-4 hours, you can get results of your MCS. You don't have to wait for 3-4 days, or like blood culture that you may have to wait for 7 days to subculture. Biotech can give you signs of growth, and you go ahead, take it through Vitek, and you get your MCS results without waiting 3-4 or a week now, you know. And next slide. And of course, there are quite a lot of medical laboratory scientists in academics, and I'm here standing before you as an academic. So we don't all have to be in the laboratory fighting for space. You know, we can actually, and there are still lots of universities. I want to test to the students if they are here, you know, if you are interested in academics. I was doing orientation for some students 2 weeks ago, and I asked them, do you want to be like me? Only 1 or 2 people raised their hands. They don't want to be a professor. And unfortunately, it was just a day or 2 days when federal government released half salary to ASU, like casual workers. You know, and these students did not raise their hands. And that is really a shame and not encouraging in our society. I was in UCH for a few years. I was so desperate, eager, the enthusiasm to be an academic, to join university was so high that when I was leaving UCH to join LAUTECH as a lecturer too, my salary, the salary they were offering me at LAUTECH was 20,000 less in 2006. And even now, 20,000 naira is a lot of money to me, you know. And people said I was crazy. But to the glory of God, I bless God. I'm not talking about money or size of pockets. But I bless God. I got all my promotion at the record time. I became a professor 2018. When I left LAUTECH, I'm #1 in the State University to the glory of God. So there is, you see, there are space for every one of us here, you know. An academic is, and I told them, scientists in academics is not just a lecturer. I tell people, and when I was in LITEC, I tell my colleagues that, look, I'm a double professional. I'm a medical scientist, and I'm an academic, I'm a lecturer, I'm a double professional. There is no way a medical scientist in academics will lack. We are not English lecturer, with due respect, or physics teacher, you know. And there are still so many space, especially in histopathology, in hematology. I'm saying this because of students that are in our midst. We need lots more people in histopathology and hematology. Some of our former students may know him, Adiola Kolawole. It's the first, that was last year, that's the first class student from LAUTECH. We never graduated any first class students in LAUTECH until last year, when this student graduated and came out first class. And I remember Professor Ali was not around, was not in Nigeria. When he came back, he said, why didn't you let this student come to medical microbiology? Because the guy graduated with hematology. I said, and of course, I brought him to LAUTECH, to the glory of God. And I said, look, I'm not going to stop this student from doing force him to do microbiology because I'm in microbiology, and also because we want microbiology to produce the first class student. Microbiology and chemical pathology are saturated. I'm not saying people should not specialize there. What I'm saying is, you do histopathology, you do hematology. As a young graduate, you will still find your skills. That's what I'm trying to say in essence, you know. And this student is in University of Chester on Commonwealth Scholarship. Started this year, October. So there are so many opportunities for you young ones in academics. And I will encourage many of you to come into academics, you know. Forget those names they give us as academics. If you say you are a lecturer, they will say, what's it called? Handout. Some LAUTECH students are here. If I ever collected any handout from you, raise your hand. You know, I give students my money to the glory of God. You know, so opportunities are there. You know, and so many grants you can access, scholarship, and so on and so forth. You know, and of course, there are some of us that are not interested in putting on ties or wait at the end of the month to collect salary. They are businessmen and women, and they are doing very well for themselves. And that is the training we have as a medical laboratory scientist. During our own time, and of course, it was only until recently that entrepreneurship was introduced by NUC. Forget entrepreneurship. The mode of our training will teach you can excel on your own without relying on anybody to give you. My father would tell, in those days, my father would say, you work for 30 days, somebody will come and give you money in one day. And you spend money on a daily basis, you know. So what I'm saying is, let's be an entrepreneur and let's think out of the box. Nation building and national security. You see, having said all this, there is no nation that can develop. There is no nation that can grow. And there is no nation that can survive. Especially, I tell people, the population of Nigeria, about 40 to 60%, I can't remember the figure vividly, comprises of youths. And our youth are highly mobile, very restless. So, what do we need to do? We need courses, programs that will give them job, wealth creation. Otherwise, we are playing with fire. And of course, as they have been saying, the government alone cannot create and do this alone. So, if we're talking of national security, we're not talking about the military, artillery, and, you know, soldiers, army, DSS, but we are talking about economic security. How do we minimize crime? The food security. If people have food, they have shelter, they have something that gives, of course, if you don't have a wealth creation, there's no way you can even have all this. Of course, there's going to be chaos and pandemonium in the nation. Next slide, please. And we all know the Sustainable Development Goal that was introduced after the Millennium Goal. And it has 17 core goals or mandates, you know. And the vision is now 2030. Nigerian government, having not met the Millennium Development Goal, of course, they have jettisoned that. And we have moved to Sustainable Development Goal to join over 190 nations in targeting 2030 to achieve these goals. If you look at no poverty, no, please, give me that other slide. If you talk about no poverty, zero hunger, good health and wellness, look at number 3, which is good health and wellness, and 11, sustainable city and communities. If you don't have a good health and good well-being, there's no way you can have sustainable city and communities. And where there is no water, there is no good environment, you cannot have a good wellness. Where there is poverty, as a matter of fact, other Western nations see Africa as, of course, we say the capital, or Nigeria, the capital city of poverty. Where there is hunger, there will be poverty. And where there is poverty, there will be disease. There's no two way to it, And that is why many people see Africa, when you say tropical, they say tropical diseases. Any disease you mention, they will say Africa. Even the one that came from Western world, at the end of of course, COVID-19 is not from Nigeria or Africa. But at the end of the day, by the time you see the statistics of Africa or Nigeria will be higher than any other countries, So that is the way they look at us, And let me not talk about Japa. Those of you that wants to go out, be ready for, what is it called now? Discrimination and so on and so forth. Be ready for that, because when they see you, God forbid, as disease, as poverty. That's the way they look at us. That's the truth of the matter. Look inward. I'm not saying don't japa. There are so many things you can do in this country as a youth without necessarily moving abroad. Abroad will soon be saturated, and many of them will be coming back. So if you look at all of this, even climate action, there's no way you can rule out the role of medical laboratory science profession or medical laboratory scientists. Because if you talk about disease eradication, we are there. If you talk about job creation or wealth creation, medical laboratory profession is there. Next slide, please. Next slide. And our role during COVID-19 pandemic cannot be overemphasized. If everybody was down during that time, the many lab scientists were at the forefront. Even in the Western world, I remember when COVID-19 came in 2019, one of my boss and my collaborator in the UK, when we were discussing, he said, it is good. I said, why? He said, people will know the importance of microbiologists. Believe me, this person is not even a medical laboratory scientist, but he's a microbiologist in academic. He said people will know the importance of microbiologists. That was what he said. And lo and behold, even, you see, it's not only in Nigeria or Africa, even in Europe, in America, some people still don't know med lab scientists exist. The belief is doctors do everything, or nurses and doctors do everything. But COVID-19 gave us some limelight and gave us a leverage in health profession. So that's why I brought this. And of course, not only in COVID-19, in various other either epidemics or Lassa fever is in Nigeria now. And we have so many I have that slide. So many lab scientists working with NCDC, Nigeria Center for Disease Control. They're med lab scientists. They're surveillance, prevention, and so on, beyond 4 walls of a laboratory analyzing clinical specimens. And this is just to show us the death rate between 1990 and 2050 of communicable diseases and non-communicable diseases. We all know the infectious disease we probably will be talking about. And of course, even if we are talking of non-communicable diseases like cancer, diabetes, hypertension, even you cannot rule out the role of those in chemical are well placed where, and hematology, where non-communicable diseases are concerned. And I mentioned Nigeria Center for Disease Control. It's the National Public Health Institute, and it's under Federal Ministry of Health. And they have a core mandate of preventing diseases, including antimicrobial resistance, which has also been regarded as a disease, in preparing for disease emergence, laboratory, and so on and so forth. Now, in medical laboratory science, yes, I said the other time that our curriculum or the courses in medical laboratory science are well placed for the challenges either of today or of the future. But we can do better. The curriculum needs to be reviewed And I know it's been reviewed, but, and it's unfortunately Professor Nhogbe is not here, who is the chairman of the HODs and deans. He will have told us where we are as far as the Medical Laboratory Science Council is concerned on Doctor of Medical Laboratory Science. We really have to do this because otherwise we'll be left out if we don't do something on this Doctor of Medical Laboratory. Fine, it is still a first degree, but we need it. We did that curriculum review in 2017 or 2018 at Abuja, at the council. But after that, I did not hear anything about it. And why I bring it forward is, I was with a physiotherapist at University of Ibadan about 2 weeks ago. I'm trying to help a particular university to set up physiotherapy. And the guy told me, well, if you can do it, it's either is DPT, which is Doctor of Physiotherapy, or nothing. That they are not giving approval to new universities to start Bachelor of Physiotherapy. That everything is settled with their council and NUC. And that gave me a jitter. He said, it's all or nothing, DPT or nothing. And he gave me the proposal that I should go and study it. If the university is ready, then no problem. Then their council is ready to move in. So where are we as a medical laboratory profession? Because it's going to further boost our students' morale. I don't need DMLS. It's a first degree. I don't need it, And so many people here don't need it anymore. But for the younger ones that are coming, and the guy was telling me, but the young ones that are interested can do 1 or 2 years, not even sit in the classrooms, and they will get the Doctor of Physiotherapy. And it will boost our morale and to encourage our new generation med lab scientists to do more, And in conclusion, medical science is private nation building. We have mentioned treatment and prevention of diseases, job and wealth creation, crime prevention and mitigation, quality education, environmental resource management, and of course, discovery, new technologies, emerging technology, and so on and so forth. Thank you so much.
Please, you can do better than that. All right, I want to thank you, sir, for that well-detailed, articulated presentation. So please, if you have any questions, I will urge you to just keep it immediately after the second presentation. We'll be having a question and answer segment. And I want to use this medium to welcome the head of Department of Medical Laboratory Science, Professor Jesse Nhogbe. You are welcome, sir. All right, so all right. I will be inviting the head of department, Professor Prince Jesse Nhogbe, to do the award play presentation to our guest presenter.
Please, excuse me, please, before the presentation. How are you, sir? What is, sir? Yeah, I said you were not around. You came late, sir. Yes, I had that. Sorry for I have to put you on the spot, sir. Sorry. Yeah, we said something concerning Doctor of Medical Laboratory Science. Other professions are doing that. Physiotherapy are starting that. No university will start any physiotherapy outside of Doctor of Physiotherapy. DPT. So where are we? I remember in 2017, 2018, we were at Abuja with the curriculum review. Can you give us information? Thank you, sir.
Thank you very much. He's a fan of mine. So Professor Obolu is a fan of mine. Occasionally I call him my son. I've been asked this question several times. The answer is still going to be the same. I chair the committee that wrote the curriculum. It was submitted to National Universities Commission. The curriculum disappeared from the National Universities Commission. We wrote it again, and it still disappeared. So what we did, I had to take about 5 other professors with me, and we went to see the executive secretary, Professor Rashid. We submitted copies of the MLSD proposal, and he said he was going to refer our submission to a committee in charge of that sort of matter. So far, we have not heard from them or from him. We discussed it just only last week when I was at Abuja, because I'm the chairman of the Committee of Deans and Heads of Department running this program in all the Nigerian universities. We believe that there is something wrong somewhere. It is not unconnected with politics. Physiotherapy got it because a member of the board of the National Universities Commission happens to be married to a physiotherapist. That was what facilitated the proposal. We shall get there. But because something happened in the past with the former chief executive of our profession, the registrar, the NEC has blacklisted us for a while. But I do hope when that is lifted, they will consider our proposal. That is the way I want to put it at the moment. It will come, but I cannot tell you when it will be. Thank you very much.
Thank you, sir. In addition to what Prof has just said, sir, I'm sure it's beyond what happened in the past when we had issues with the NUC. In all health professionals or professions, our rival, I don't want to mention name, they don't have any problem with any other profession. Nurses are not their problem. Pharmacists are not their problem. See, it is medical lab. Sir, we have to change our tactics. That's the truth of the matter. I'm 100% sure, because I was at that meeting at Abuja. NUC sent a representative. Ministry of Health sent a representative. So we thought at that time everything was closed. You know. So it's beyond that. They don't have problem with any other professions. In many of these things, or whatever development and progress, we are always left behind. This one we should not take last. Thank you.
Thank you very much. Hello, Professor David Ogboru, stood in for Professor O.A.T. Ali, and I'm going to present this award to Professor Ali through his representative. Therefore, sir, I want to present to you, on behalf of the Medical Laboratory Scientists of Nigeria, Babcock University / Babcock University Teaching Hospital Chapter, an award of excellence to Professor A.O.T. Ali through you. Thank you very much, sir.
Thank you. On behalf of the recipients, I want to say thank you. God bless you all.
All right, like I did said, let's just note our question down. Immediately after the second presentation, we'll be taking questions and answers. So we'll be moving straight to the second presentation, and it is titled Personalized Medicine, the Rule of Molecular Techniques. I'll be inviting Associate Professor Adejumo to come forward. While MLS Damilola Chemical will be reading her citation.
Good morning, everyone. Standing on the existing protocol, I would like to read the citation of Associate Professor Esther Ngozi Adejumo. Esther Ngozi Adejumo is an Associate Professor of Chemical Pathology in the Department of Medical Laboratory Science, Babcock University, Ogun State, Nigeria. She completed her PhD in Chemical Pathology from Olabisi Onabanjo University, Ogun State, Nigeria. She is a Fellow of Medical Laboratory Science Council of Nigeria and a Fellow of West African Postgraduate College of Medical Laboratory Science, Clinical Chemistry. Dr. Adejumo started her career as a medical laboratory scientist in the Department of Chemical Pathology at Ahmadu Bello University Teaching Hospital, Buth, Zaria, Kaduna State. Thereafter, she had a short stint in private practice before she joined the Department of Chemical Pathology, Olabisi Onabanjo University, Ogun State, Nigeria. She transitioned into academics at Babcock University. Her research interest is in obesity-associated metabolic disorders with a passion for metabolic syndrome, cardiovascular diseases, and more recently, molecular diagnosis. She has published over 35 scholarly publications in local and international peer-reviewed journals. Dr. Adejumo is a member of the following associations: Association of Medical Laboratory Scientists of Nigeria, Association of Female Medical Laboratory Scientists of Nigeria, Society of Chemical Pathology Scientists in Nigeria, Association of Clinical Chemists of Nigeria, and Nigeria Society for Immunology, and also African Society for Laboratory Medicine, and also International Association of Public Health Logisticians and Global Women in Science. With a loud ovation, I would like to welcome Associate Professor Dr. Esther Ngozi Adejumo.
Thank you very much, Damilola. Good morning, everyone. I would like to stand on the existing protocol. I'd like to appreciate my HOD, Professor J.C. Hongbe, such a wonderful father to all of us. I also like to appreciate the last speaker, Professor Bolu. Thank you for being with us again. He was with us some weeks back. He came to represent the council for our first professional exam. I also like to acknowledge my dear colleagues. I have senior colleagues in the house. Some of them that I worked with in Olabisi Onabanjo University. I can see Mr. Mosuru. In fact, we're sharing the same office then. You're welcome, sir. Thank you, wonderful students. This is home because I'm a member of the hosting chapter. I've been asked to make a presentation on the topic titled Personalized Medicine, the Role of Molecular Techniques. What happened? Huh? Okay. No, it's mine. And I'll be following this outline. It's just going to be maybe some overview and then maybe some things that might be beneficiary to our students in particular. Next slide. When I was asked to talk on the topic personalized medicine, the first question that came to my mind was, why personalized medicine? And so if it is not personalized medicine, what then is it? And well, if it's not personalized medicine, then it will be conventional or traditional medicine. And looking at the picture at the background, I discovered that conventional medicine is a kind of medicine that seems to describe every one of us to fit into one cloth size. But even when it comes to clothes, we know that all of us cannot wear size 18 in this hall. So it's the same thing with the practice of medicine. Everybody cannot be categorized into one group based on maybe some kind of diseases. I would like to emphasize the importance of personalized medicine, the importance of molecular diagnostics, the importance of molecular techniques, and even the importance of medical laboratory scientists in the practice of personalized medicine using a true life story. It has to do with a cousin of mine, actually. A few years back, he was diagnosed with cancer of the lung using conventional diagnostic methods. He did some imaging techniques, MRI, CT scan, he did biopsy, and all that. And then he was told that he had cancer of the lungs. And they actually started him with conventional chemotherapy, radiation, and all the rest of them. Instead of him to get better, he started deteriorating, and then there were several side effects. In fact, at some point, we thought that we were going to lose him. And so we decided to seek for more opinions. And that was when we met an oncologist that decided that he would sequence the tumor. In fact, that was the first time I was actually hearing it. And it was done somewhere in a lab here in Nigeria. And then when the result came out, we were told that his own kind of tumor was peculiar because he had some specific mutation, and that the drug that he was being given was not working for that particular kind of mutation. So he was given a generalized treatment. Well, with the new diagnosis, he was now placed on some special drugs that could address that particular mutation. And I bet you that my cousin is doing very well now. It looks like a miracle then, and it really is, but with the understanding I have now of personalized medicine, I know that that is the benefit of personalized medicine. I also know that it was that sequencing of that tumor that helped us to know the specific mutation that was responsible for that cancer. And so that tells me the benefit of molecular diagnosis and then the molecular techniques that were used. Because, well, as I got to know, it was the tumor was sequenced actually, so a particular molecular technique was used. And even the person who did that work in that particular lab was a medical laboratory scientist. And so that even showed me the scope or role of a medical laboratory scientist in the practice of personalized medicine. Next slide, please. The truth is that personalized medicine, even though I know so many speakers referred to it yesterday, it's not a new concept. It's kind of being in practice in maybe a different way, kind of, because this quote that we have here was made by Hippocrates, who we all know is the father of medicine. And then he said it is far more important to know what person the disease has than what disease the person has. Here he was laying emphasis on the person, understand this person with this disease, rather than have a generalized concept on the disease. The only thing is that nowadays, the concept of personalized medicine has become more popular, because we're all beginning to have better understanding of the molecular basis of disease. We now have tools that can use to do genome sequencing we now have data from the Human Genome Project. Move to see a bit of that. And then, I mean, so many other advances. So that's why I look at personal medicine is becoming a more popular concept now. Next slide. Okay, there were several definitions of personalized medicine I came across, but I saw that they had some kind of similar concepts, you know. So I will read what I have here. It says, personalized medicine refers to the grouping of patients based on risk of disease or response to therapy using diagnostic tests or techniques. I've deliberately highlighted some things in red. Some major goal of personalized medicine is the ability to identify individuals that have risk of some particular disease. So some molecular techniques are used to identify those individuals that have a risk of some particular disease. Personalized medicine also involve identifying individuals that will respond in some specific way to therapies. That will help to give therapies that are precise and effective. Just like in the case of my cousin that I talked about, you know, they had to identify the particular mutation that was responsible for that cancer. And that's how he was able to be given some specific therapy that has really improved his health status now. Importantly too, personalized medicine uses diagnostic tests or techniques. And that's where these molecular techniques that we are talking about comes into play. Because in actual fact, from the second definition, personalized medicine uses an individual's genetic profile. And the only way we can understand or study an individual's genetic profile must be the use of molecular techniques. Basically, personalized medicine is focused on prevention, diagnosis, and treatment of diseases. We'll see this as we go on. And it's important for us to know that sometimes when we check up for personalized medicine, in fact, I had that challenge, what we'll be seeing is more of precision medicine, individualized medicine, stratified medicine, and then P4 medicine. And what is this P4? It's a combination of preventive, predictive, participatory, and personalized medicine. Okay, so like I said, much of personalized medicine now is being driven by data for the Human Genome Project. So what is this Human Genome Project about? It was an international scientific project, a very large one, that took place between the year 1990 to 2003. And the aim then was to determine all the nucleotides in human DNA, as well as to know the number of genes that are present in the human genome. You know, and then a molecular technique was used even to carry out this project. And that technique then was the Sanger sequencing technique. It had its fair share of limitations, you know, as such, at the end, only 92% of the human genome was actually sequenced. But currently, we have a report that as at March of 2022, scientists have published the complete gapless sequence of the human genome, and that's a big feat. Importantly, this project gave us something like a reference genome that we can use to compare any individual's genome, the genome sequence, you know, to look for those alterations that are associated with diseases. So that's one importance of this project. Okay, importantly too, from findings from the project, it said that the human genome has approximately 3.1 billion base pairs, and all humans have about 22,000 to 25,000 coding genes. It's also intended that in the near future, every human will be able to sequence their genome, and this will become part of routine care for everyone. Well, for now, it looks like it's a big feat or a difficult one, but I was conversing with somebody recently, and then the person was telling me that the price for whole genome sequencing was getting cheaper. I know that when the project started abroad, they were trying to do some things to peg it at $1,000, but the person was telling me that even for as low as $200, one can do whole genome sequencing. That's still much for us, but I believe that over time it will get cheaper. And I'm sure so many of us would like to maybe sequence our genome. The advantage in it is that when you have your whole genome sequenced, you know, one can look at it and compare it to the reference genome and then see alterations that may be associated with diseases that can be prevented, because one can maybe adopt some lifestyle factors that can modify, you know, the occurrence of this disease. Okay, so this is what a section of that human genome sequence looks like. I just wanted us to see what it looks like so that it won't be an abstract information. So basically, if you can see the picture well, you see that it's made up of alphabets that are arranged. And those alphabets are the alphabets that denote the nucleotide base of DNA. So we have A, T, G, C, representing adenine, guanine, thymine, and cytosine. And they're not just randomly placed there, they're actually arranged in a particular successive order, So this is like the reference genome. So it's important for us to know that in some cases, there could be alterations in this arrangement. In place of maybe an A in a particular position, we can have a C or a T. And those are the kind of things that are referred to as mutation. And mutations, though not all of them can cause disease, some of them are actually silent, some of them are nonsense, but some of them are referred to as missense mutation, and as such, they can cause disease. And it plays an important role to even in personalized medicine. Next slide. Okay, so what are molecular techniques? From several of our presentations, we have seen different kinds of techniques that can be used in medical laboratory science. But specifically, molecular techniques are those ones that are used to study or investigate or measure nucleic acids like DNA, RNA, and then proteins too, not just metabolites that form from this process. It's important for us to also know that all specialties in medical laboratory science can actually practice molecular techniques. The practice of molecular techniques cut across all specialties of medical laboratory science. I'm saying that, and I put that in red because I remember that when I was doing my PhD, I had some friends who were in medical microbiology, and whenever you ask them, they'll tell you we are doing molecular techniques. Meanwhile, I was just doing my serum markers and all that, so I was feeling like, and all that. And I've also interacted with people, even students, that feel that it's only medical microbiology I can do molecular techniques. That's why I want to specialize there. So whether you're in hematology, chemical pathology, histopathology, immunology, you can always do some molecular diagnosis, whether for research purpose or for diagnostic purposes. There are several types of molecular diagnostic techniques, but I just gave a few examples that, are common to us, like the polymerase chain reaction. Then we have the DNA and RNA sequencing methods, and then gel electrophoresis. I put the DNA and RNA sequencing methods there because that's the method that was used, to sequence the whole human genome during the whole human genome project. Also, quickly, so what is polymerase chain reaction about, especially for the benefit of our students? It's a kind of reaction that is used to rapidly produce DNA in the laboratory. And why do we need to produce DNA in the laboratory? Because we want to do some analysis, and the amount of DNA that is usually present in the sample is usually so small that it cannot be detected, it cannot be quantified, it cannot be used to do some other procedures. So we need a way of increasing the quantity so that we can do what we want to do. So it is used for the application of specific gene targets or small DNA fragments. It takes place in 3 steps actually, and a completion of these 3 steps is referred to as a cycle. The 3 steps are temperature dependent, they take place at different temperatures. So usually to start with a double-stranded DNA, and then during the step of denaturation, the double strand, the hydrogen bonds, putting the double strands together is broken, and then the DNA is separated into 2 separate single strands. This is what forms the template for the next step. In the next step, that actually happens at a temperature of 95 degrees centigrade. In the next step, which is the annealing phase, primers are annealed to each of the single strands of the DNA, at a temperature of about 55 to 60 degrees centigrade. And then at the last step, which is the elongation or extension phase, some special kind of DNA polymerase that are heat resistant, is known as DNA tag polymerase, begins to add complementary nucleotides to extend the primer. At the end, we have a duplicate of the original number of DNA that we started with, and each of these new DNA will have 1 strand from the old DNA, and then a new strand that has just been newly synthesized in the laboratory. Usually, PCR will take place in repetitive circles, so many of them, such that at the end of each circle, we are getting duplicates, as you can see here. So at the end of the first circle, we have 2 of the original DNA that we started with, By the third cycle, we're having 8. And then by the 20th cycle, we're having about 1 million copies of the same type of DNA. And I mean, even up to billions, as you can see there. So we have sufficient DNA to be able to carry out whatever reaction that we want to carry out in the laboratory. Next slide. Okay, so there are several types of PCR too, but I just brought out these 3 that are commonly used too. We have the conventional PCR. It's actually a qualitative method. It does not quantify at all. And one thing about it is that before you can even get to know what has happened, it will only be at the end of the entire process of amplification. We also have the real-time PCR. That one is the quantitative method, and one can begin to know what is happening in the reaction as the process goes on, and that's why it is called a real-time PCR. Then lastly, we have, on my slide, we have reverse transcription PCR. This one is used to amplify RNA, especially like viruses that have RNA. And what happens is that an enzyme that is known as reverse transcriptase is added to the reaction, and it transcribes the RNA into complementary DNA before the process of amplification begins to take place. Okay, so another one, technique we'll talk about briefly is the DNA sequencing technique that was used in the Human Genome Project. Well, as it says there, it says that it's a powerful tool because it reads, unlike PCR that will just amplify or increase the number of DNA. This one will read the individual nucleotides that make up that sequence. And it's of importance because as it reads it, it will also tell us their positions. And knowing their positions will also help us to know whether there's an alteration, in that sequence. And these alterations, like I said earlier, some of them, especially if it's a missense mutation, is associated with disease. DNA sequencing or even RNA sequencing, they're actually a 2-step process. We have the wet lab part and the dry lab part. The wet lab part is the part that has to do with the synthesis of the amplicon, while the dry lab part involves the use of a computer to interpret the information or data obtained. Well, generally, there are 7 basic steps, but the thing is that there are different methods of DNA sequencing or sequencing. There has been the first generation, the second generation, and the third generation. So importantly, it's best to follow the manufacturer's instruction or protocol or standard operating procedure. But I'll just use, next slide, this diagram to maybe explain briefly what happens. So there's the first phase, which is the extraction of DNA, whether it's from blood, from tissue, or whatever that needs to be sequenced. And then that DNA, because it's long, it needs to be fragmented into smaller pieces that can be sequenced or read accurately. After that, each of the fragments are arranged in sizes, according to their sizes, and stored as a library. After that, if there's any segment that is of interest at that particular time, that can be taken, and then using PCR techniques, it is amplified in the sequencer. Basically, what that machine you can see there, which is a sequencer, what it does is that it will read these nucleotides, and then it will generate a signal. That signal will then be picked by a detector and transferred to a computer that does the final job. Next slide. So this is a picture of what we can see on that computer screen. We can see signals denoted in various colors, and then we can see it interpreted into the representative nucleotides. The computer also has a software program that can also further interpret the result. For instance, we can see a comparison between a reference genome and then the one that is being analyzed. And we can see that highlight in red, the C and the G, showing us that there's an alteration in that particular position. That alteration may be indicative of a disease condition. So that's one usefulness of DNA sequencing. Okay, so what are the applications of molecular techniques in personalized medicine? I've categorized it into 2 based on the definition of personalized medicine. It said that it has to do with identifying individuals who are at risk of a particular disease. And what happened is that molecular techniques can be used to identify individuals who are at a risk of particular diseases, because the molecular technique will be used to understudy or investigate the individual's molecular profile. The important thing about it is that such individuals can be advised on preventive strategies that they can adopt to either completely stop the occurrence of that disease or delay its occurrence. And so that's what I've referred to there as personalized prevention. It can also be used to offer personalized treatments. You know, like the story of my cousin that I told us about, they had to sequence that tumor and study the mutations. And on that basis, they gave him a personalized treatment that was actually addressing the defects in that tumor. So it's used to provide treatment that is tailored to meet the needs of an individual's genetic profile. Okay, so I want to use just 2 examples to actually illustrate this personalized prevention and personalized therapy. One common example that comes to my mind has to do with cancer, you know, just for illustrative purposes. Molecular techniques such as PCR, the Sanger sequencing technique, next generation sequencing can be used to identify individuals who are at increased risk of some diseases. And one common example is those individuals that increase risks of breast cancer. For some of us, we know that breast cancer can be inherited, you know. These molecular techniques can be used to check for the presence of breast cancer 1 and breast cancer 2 genes that are mutated. And individuals who have this kind of mutation are said to have a higher risk for breast and ovarian cancer compared to the general population. You know, so it has placed them in a particular category. So those kind of people can then benefit from personalized prevention. And what kind of personalized preventive strategies can they benefit from? Such individuals can be advised to do what is called enhanced screening. And so they have to screen for breast cancer more often than the general population. Where other women will just be doing breast self-examination, those ones will have to incorporate some more intensive methods, such as the use of mammogram and MRI techniques, just to ensure that in case anything is happening, they are able to detect it early enough. Such people can also benefit from other preventive strategies, such as risk reduction strategies. You know, I don't know, some of us may have heard of stories of women that had to go for double mastectomy, you know, because they tested positive for BRCA1 or BRCA2 antigen. Some people also have to go for surgery to remove their ovaries and fallopian tubes because they supply hormones that can, enhance the occurrence of this disease. Okay, so for personalized treatment, before personalized treatment will come personalized diagnosis, like in the case of my cousin that I talked about, you know. Using the conventional diagnostic methods, they just classified him as having lung cancer. But when they did some further investigations that required the use of molecular techniques, they now were able to detect some specific gene mutation. So what I have there are just examples of gene mutations that can cause non-small cell lung cancer. That's what I have there. So I want to use this next slide to illustrate this personalized treatment. So assuming we have 3 people who have cancer of the lungs, you know, and then using conventional diagnostic methods, you know, they're just classified as having cancer of the lungs, you know, but using molecular techniques, you know, and then studying the molecular profile of the tumor, such individuals could be seen to have different kind of genetic mutation in the tumor. And so in this case, we have these 3 individuals who actually have 3 different genetic mutations in their tumors. And for that reason, they are given 3 different therapies, because these are therapies that will actually inhibit the proteins being produced by these particular genes. The genes I'm talking about here are actually tumor suppressor genes. They prevent the growth of tumors, but when they are defective, you know, tumors can just grow. So what are the benefits of implementing personalized medicine? They include improved prevention through screening, like I explained, using the BRCA1 and 2 gene. They include improved survival rates for diseases. At least my cousin is surviving, and we believe that he will survive to good old age. They include reduced adverse effects of treatment, because when conventional or generalized medicine is used, some of the individuals will not respond to that particular therapy, because their genetic mutation, their genetic profile is such that it's not responsive to that particular therapy. As a result, they may have some adverse effects. It also helps us to avoid wasting money on treatments that are not effective for a given patient. Now, what are the challenges? These challenges are not challenges of personalized medicine per se, directly, but they are challenges that have to do with molecular diagnostics and molecular techniques. And like we heard severally from many of the speakers yesterday, there's a challenge of manpower. We don't have as much people who are skilled in molecular diagnosis as we should. And that's one major purpose for this conference, to update us with knowledge as well as to empower us with skills. I remember that early this year, I participated in a training that was organized by the molecular lab for this teaching hospital. And they had some little things to teach us, as small as good pipetting techniques, you know. And when I saw it, I was like, this is too elementary now. What is this all about? But the truth was that when I was tested, I didn't pass. I couldn't pipette very well, you know. So they had to teach us some rudimentaries, you know, that we overlook. So it's as small as that, you know. And then even with the constantly evolving technologies that are used for kind of molecular techniques, it's important for us to continuously have updates, capacity building, so that we can be able to use these equipment, particularly because we need them to be able to practice or to take our place in personalized medicine, because personalized medicine is dependent on evidences that we can generate from an individual's genetic profile. Another challenge is the cost of equipment, reagents, which transcends to the cost of the test itself. You know, these equipments, they're automated, very expensive, many of them have to be imported and all that and everything. I know a friend that just set up a lab for someone, and she was telling me it runs into millions and millions. So at the end, the cost of the test will be so high that it's not pocket-friendly for those people who should benefit from it. And so such people may not necessarily benefit from personalized medicine because they can't afford to pay for the test. Then we have issues of power source and electricity. We're all in Nigeria, and we know the common trend. Light is quite not stable. We are just blessed to be in this environment, you know. And I know that many of us in our houses, what we do now is personalized electric supply. Some of us have inverters, some of us use solar system and all the rest of them. So that's a challenge for us here, because most of these reagents are actually cold supply chain commodities. The instruments too, they have to be kept cold, you know, so it's a challenge. And then lastly is awareness, and that's why we are here. We want to keep ourselves abreast on these techniques, on molecular markers, on things like personalized medicine, the benefits of molecular techniques, and even the people who are supposed to use these services too. They need to be aware of things like personalized medicine. For instance, my cousin didn't know anything. We were just fortunate to meet an oncologist that knew that diagnosis could go beyond the conventional, just biopsy and all the rest of them. And that's how we're able to get an accurate diagnosis that may then give him a personalized treatment that is still sustaining him till date. So in conclusion, I would say that molecular techniques play a key role in the delivery of personalized medicine. It is therefore essential for medical laboratory scientists to continuously update their knowledge and skill so as to, and then what I have in quotes is in quotes because I adapted it from the statement of our chairman. He said, so as to remain relevant in today's scientific world, and as well as in the practice of personalized medicine. Thank you very much for listening. The truth is, I want to appreciate my chairman. I'm here by the grace of God, but you will not understand. I just thank God for God. I thank God for my chairman. He has been very encouraging and supportive. I just thank God for everything. Thank you very much.
All right. I must say women are unique, and I like them. You know why? You know why? Let me tell you why before you clap. You know, women, they like everything foreign. They like foreign things well. Their hair na Brazilian hair. Their wears na Italian wears, Italian shoes, Italian bag. Even for food with the one cook na Cameroon paper they like use. Now so they just be. So we'll be moving straight to the award presentation. I'll be inviting Professor Rena to do this presentation to this special woman that is standing here. Professor Rena, is she around? Okay, he's around, sir. Oh, welcome, sir. All right, let's. All right, Professor Rena is the Dean of Clinical Services. He will be doing the presentation to Dr. Mrs. Adejumo.
Distinguished ladies and gentlemen, I came in at a point where Dr. Adejumo was giving her lecture. I have enjoyed every bit of the lecture, and I've learned about wanting me to get all the various things that you have asked us to get if we can't get them. I hope that we will be able to ask the people who can make them available to consider the economy of our nation so that we can buy some of those things that you suggested. I commend you. The task that I've been given is to give you this award, and what it says is, as the Association of Medical and Laboratory Scientists of Nigeria, Babcock University Teaching Hospital, awards is presented to you, Dr. Esther N. Adejumo. Personalized medicine, the role of molecular technique. You are the speaker. Today, 30th November 2022. So it's my pleasure, ma'am, to give you this.
Once again, I would like to thank this association for this recognition, and I'll say it again, I want to thank my chairman for his encouragement. God bless you. Thank you.
Sorry, ladies and gentlemen, I just quickly had to come up because I would like to appreciate very specially. He has been called upon, but yesterday I called someone, a friend of the profession, our deputy director HR in Buth here. Another person I regard as a friend of our profession is Professor Rena, Dean of Clinical Sciences, Babcock University. There is hardly any program we invite him to that he doesn't attend. He will sit and attend and listen and contribute. Once again, please can we appreciate this elder and professor. God bless you so much, sir. And then I also like to appreciate the speaker, Associate Professor Adejumo. So many things have gone on behind the curtain, but I'm sure we all saw that her presentation was top notch. Is that not it? Please let us appreciate her. She's a woman of timber and caliber. Thank you so much, man. God bless you. God bless you.
All right, we'll be moving straight to the questions and answers segment. I don't know if we have any questions for the last two speakers. Do we have questions? All right, 1, 2. All right, you can come up, please.
My question is for the first speaker, medical lab science beyond diagnostic services. I wonder if the speaker has anything for us on the role of medical laboratory scientists with regards to biological weapons.